Alright, welcome back to this session again, and of course we are still discussing trigonometry. In this particular session I'm going to be discussing quadrants. First quadrant, second quadrant, third quadrant, and of course the fourth quadrant. And this is what we mean. Alright, if I pick a circle and divide it into 4 parts, each of them is called a quadrant. If I pick a circle, permit my circle here, and divide it into 4 equal parts. Sorry, my circle looks strange, but let's manage it. If I pick this circle and divide it into 4 equal parts, each of this is called a quadrant. Angles in trigonometry are measured anti-clockwise. So I'm going to start from this point to measure, okay, till I come back to this point, and all of that will give you, of course, 360 at the end of the day. Alright, so we divide our circle into 4 equal parts. At this point I have 90 degrees. We call this guy the first quadrant. We call this guy the first quadrant. At this other part I have another 90 degrees. This guy is called the second quadrant. Here I have another 90 degrees. This guy is called the third quadrant. Okay, and finally I have another 90 degrees, and this guy here is called the fourth quadrant. This guy here is called the fourth quadrant. If you add all the 4 right angles together, 90 plus 90 plus 90 plus 90 will give you 360. And you know that sum of angles in a circle is always 360 degrees. Alright, we'll go to the first quadrant. If I consider a radius, which is r, and I consider this my lines at the center of the circle to be the Cartesian system of x and y axis. Okay, so this vertical guy corresponds to my y axis, and this horizontal guy corresponds to my x axis. So I pick an angle here, inside here I call theta. So you can see that my sine theta, my cos theta, and my tan theta with respect to the first quadrant. Okay, let me put it under the first quadrant here, since we are dealing with first quadrant. So for this first quadrant here, I have sine theta, I have cos theta, and I have tan theta. Alright, now for respect to theta, now I'm having what is called, the opposite side here is y, as you can see on the screen, is y, opposite angle theta. My hypotenuse is r, which is the radius of the circle. You know, from the center of the circle to the circumference is the radius, which is r. So if I'm talking about sine theta, then I'm referring to opposite is y over hypotenuse is r. If I'm talking about cos theta, adjacent now is x, all over hypotenuse is r. And if I'm talking about tan theta, opposite over adjacent, which is y over x. Y over x. Now what you can observe here is that all my trigonometric ratios are positive in the first quadrant. An angle in the first quadrant is between 0 degrees to 90 degrees. So if I have theta as an angle in the first quadrant, that means that 0 degrees less than or equals to theta less than or equals to 90 degrees. Angles in the first quadrant is given as from 0 degrees to what? 90 degrees. If you find the value of anything between 0 to 90, it will always return a positive value. Sine 30, cos 30, tan 30, anything between 0 degrees to 90 degrees will always return a positive value. Permit me to draw another circle here and start fixing that guy up. So in the first quadrant here, we have what is called A. A means all the trigonometric ratios are positive in the first quadrant. Alright, we now move to the second quadrant here. I also consider an angle here, which is called, I also consider my radius here, which is called r. I'll dot this down to the vertical side, and of course this guy is still the horizontal, which is x-axis. You know, those lines represent the x and y axis. I have an angle here in this that is called theta. Alright, now this guy here, the vertical is still y, that's positive y. From the center of the circle up is positive y. But the left hand side now is now the negative x-axis. So what I'm having here is the negative x-axis now, minus x. So for the second quadrant now, I can also look at sine theta, cos theta, and also tan theta. Alright, so with respect to this angle theta, sine theta is now opposite is y, all over hypotenuse is r. Cos theta is adjacent, which is now minus x, that's the negative x-axis now, divided by the hypotenuse is r. And also tan theta is opposite, which is y, all over the adjacent is minus x. So you notice that cos is negative, minus x over r, and tan is also negative, which is what? minus x over r is only sign that is positive. So I come to this other circle here and represent that in the second quadrant I have ace. Ace means only sign is positive. Angle in the second quadrant is from 91 to 180 degrees. So we have, if theta is an angle in the second quadrant, then we write this as 90 degrees less than theta less than or equals to 180. 90 degrees less than theta means theta is greater than 90 degrees. That means from 91. So it's from 91 to 180. Now, if you find the value of sine 150 degrees is more than 90 but less than 180 or equal, yeah, it's less than 180. So that means it's in the second quadrant. Sine 150 degrees will give you a positive value, which of course is actually 1 over 2. Okay, now this is how I evaluated that. Angle in the second quadrant is given as 180 minus theta. So if I'm asked to find the value of 150 degrees, it means 180 minus 150 giving me 30 degrees. So sine 150 means sine 30 degrees, and sine 30 degrees gave us half. So that is how sine 150 will still give us 1 over 2, which is 0.5. You can check with your calculator. If you have to find something like sine 120 degrees, sine 120 degrees means sine 180 minus 120, which will give you 60 degrees. So sine 120 is the same thing as saying sine 120. Sine 120 is the same thing as saying sine 60 degrees, because 180 minus 120 will give you 60 degrees. And sine 60 degrees is root 3 over 2. Alright, so that means I'm going to have the same positive value. Alright, if you have to find something like cos 150 degrees, for instance, when we are solving trigonometry equations, you see how we'll be interpreting this. If you have to find cos 150 degrees, that value will give you a negative value of cos 30. The angle in the second quadrant is 180 minus theta. So evaluating cos 150 means cos 180 minus 150, which will give you 30 degrees. 180 minus 150 is 30. So cos 150 means cos 180 minus 150. So cos 150 means cos 30 degrees. And cos 30 degrees gave us root 3 over 2 from special angles I did earlier. But cos in this quadrant is negative. So I'll be having a negative value of that. Press your calculator. Cos 30 as if it's in the first quadrant will give you a positive value. But if you press cos 150, it will give you a negative of that answer. Alright, because cos in that quadrant is negative. The same thing is applicable to tan in that quadrant. So we are done with the second quadrant. We now move ahead to the third quadrant. I also draw a radius which is r, from the center of the circle to the circumference as r. I will map this guy down. Sorry, let me draw my radius well, so that, okay, this is the radius of the circle, which is r. So I also map this guy down, and I have an angle inside the third quadrant here that is called theta. Now my adjacent side is still minus x because that's the negative x-axis. Now the opposite side now is now minus y. You know, from the center of the circle down, the vertical line now is now negative y-axis. Okay, so we have minus y. So with respect to this third quadrant now, I can also talk about sine theta, I can talk about cos theta, and I can talk about tan theta. Okay, so sine is opposite, which is minus y now, over the hypotenuse side is r. Okay, now cos is adjacent, which is the minus x-axis now. Minus x over hypotenuse is r, and tan is opposite over adjacent, which is minus y over minus x. So minus minus will go, so it's the same thing as saying y over x. In the third quadrant, is only tan that is positive. So you have come back to this other smaller circle and put t. Okay, so in my third quadrant is only tan that is positive. Angle in the third quadrant is given as 180 plus theta. 180 plus theta. In the first quadrant, angle is theta, and theta lies from 0 degrees to 90 degrees. In the second quadrant, angle is 180 minus theta, and theta lies between 91 degrees, that's from 90, that's 91 to 180 degrees. Now in the third quadrant, the angle is something greater than 180 now, but less than or equals to 270. So we have 180 degrees less than theta, less than or equals to 270 degrees. That is the range of values for the third quadrant. Alright, so here I'm looking at something greater than 180 but less than or equals to 270. For instance, you have to evaluate sine 240 degrees. Sine 240 degrees. Now you break it down here as 180 plus. What will I add to 180 to have 240? That is 60 degrees. So that means theta now is 60 degrees. Finding sine 240 is the same as evaluating sine 60 degrees. Because 240 means 60 degrees in the third quadrant. Angle in the third quadrant is 180 plus theta. So if they give you something like 225, what's the value for cos 225? You are asking yourself, what will I add to 180 to have 225? That will be 45 degrees. So finding cos 225 means finding cos 45 degrees. And finding sine 240 means finding sine 60 degrees, because you are adding 60 to 180 to have the 240. Alright, so in that quadrant, it's only when you are trying to evaluate tan that will be positive. Any other thing different from tan, of course, will be negative. So sine 240 means sine 60 degrees, and sine 60 degrees gave us 3/2 from our special angles. Since sine is negative in this quadrant, you now attach a negative sign to that. If you pick your calculator now and press sine 240, you are going to have the negative value of pressing sine 60 degrees. Alright, so it's going to be negative. It's only tan that is positive. And finally, when we get to the last quadrant, which is the fourth quadrant, we now have something like this. Our radius here is still r. We map this guy down, the vertical axis, which is still minus y axis, because that's down, and this adjacent side is now our plus x axis, so x is still maintained there. Okay, so at this place now we have an angle that is called theta. So we also pick it out: sine theta, cos theta, and also tan theta. So with respect to sine, sine is opposite, which is minus y now over the radius is r. Cos is adjacent, which is x axis now with respect to this triangle here inside this fourth quadrant. The adjacent side is x over the radius is r. And finally, tan is opposite, which is minus y over adjacent is x. So with respect to the last quadrant, you can see that it's only cos that is positive. Only cos that is positive. So here we come here and we put C. That is the summary. Now on my next screen, let's summarize what I just did. This is what I just did. If you pick a circle and divide it into 4, this is what is called the first quadrant. This is called the second quadrant. Angle here is measured anti-clockwise. Okay, this is what is called the third quadrant, and this is what is called the fourth quadrant. In the first quadrant here you have A, and A here means all the trig ratios are positive. Angles here, the range of angles here is between 90 from 0 to 90 degrees. In the second quadrant here you have A's, meaning only sine alone is positive. Okay, so angle in the first quadrant here is theta, angle in the second quadrant here is 180 minus theta. So here you'll be asked to evaluate something more than 90 but less than or equals to 180. Alright, so in the second quadrant is only sine that is positive. In the third quadrant is only tan that is positive. An angle in that quadrant is given as 180 plus theta. So if you have to find something like the 225 I talked about, what will you add to 180 to have 225? That's 45 degrees. So finding tan 225 means finding tan 45 degrees. And from special angles, tan 45 degrees gave us 1. So tan 225 will also give us the value 1. And in that quadrant, tan is positive, so we have plus 1. And finally, in the fourth quadrant, you have C standing for cosine, meaning that it's only cosine alone that is positive. And the angle in that quadrant is 360 minus theta. So here you'll be asked to find something more than 270 but less than or equals to 360, something like 300 degrees. Okay, if I'm asked to evaluate sine 300 degrees, that means 360 minus 300, that will give me 60 degrees. So evaluating sine 300 degrees is the same as evaluating sine 60 degrees. You need to be able to break these angles down to a special angle of 30 degrees, 45, 60 or 90. So finding sine 300 degrees means finding sine 360 minus 300. That gives me 60 degrees. So sine 300 means sine 60 degrees. And sine 60 degrees is root 3 over 2. And since in that quadrant sine is negative, so you add a negative value to that. You have minus root 3 over 2. This is the summary of the quadrants. Back then in school, since you are starting from the first quadrant, you can make a simple statement like all students take coffee. A for all students take coffee. That is the summary of the quadrants we have. All A means all the trig ratios, sine, cos and tan, with their inverses too, cosec, sec and cot. Everything between 0 to 90 degrees will give you positive values. Second quadrant, only sine is positive, meaning inverse of sine, which is cosec, will also be positive. The rays will give you negative values, including their inverses. Third quadrant, only tan is positive, meaning the inverse of tan, which is cot, will also be positive. Every other guy, which is sine and cos now, with their inverses too, will also be negative. And finally, in the last quadrant, what we have is cosine being positive, meaning inverse of cos, which is sec, will also be positive. Every other guy there will be negative. That has been our session as far as quadrant is concerned. Now, in summary, in the next session, we'll be using all what I've discussed since I started this particular topic to solve some problems, and I'll be looking at trigonometric equations. I will be able to use all these things to interpret and be able to solve a particular trigonometric equation. Don't go anywhere. See you in the last session as far as trigonometry is concerned. Bye for now.